Hi, everyone. I hope this finds you doing well and staying healthy. I want to show a demo of some Apex code completion enhancements in Illuminated Cloud for something called Postfix completion. Postfix completion is a feature that has already existed in the JetBrains IDEs for their built-in languages. It's something I've been meaning to add for Apex for quite a while, and I finally just kind of bumped it up to the top of my priority list. It's very similar to live templates that I imagine many of you have used quite a bit in the past. Those things where you type like iter or SD or SEL star, and it generates some code for you. Taking into account potentially some contextual information, often prompting you for that contextual information. The primary difference is going to be that a postfix completion template starts with an existing expression, so it doesn't necessarily have to prompt, and it can therefore take advantage of more complex expressions, indirect expressions that have already been typed. Having said all that, this is one of those things that probably is best conveyed through a demo rather than me rambling on for a long time. So why don't we just dive into it? I'll walk through and provide demos of each of the out-of-the-box postfix templates I've included for Apex in this first version. At the end, I'll talk about what the future of this might look like based on feedback from users. So I will do a little compare and contrast between a postfix template and its existing live template, especially because that'll kind of ground things in something that already existed. But I won't do that for each one, just a couple to kind of set the pace. So why don't we start with the ability to log statements, to log information. So traditionally with a live template, the things that already existed, if I wanted to log something from this account, I'd say SD. You can see that's a live template, has a little rubber stamp beside it, says what it's going to do, debug logging with system.debug. I'd hit tab and it would put me in the body of system.debug. And then I could say like account.annual revenue, and I've done that. The way that a postfix template would work is I would say account and a dot annual revenue dot SD. Now it looks like I'm actually specifying a property, a field of annual revenue, but really what I'm doing is saying for the expression that I am completing right now, I want to apply this postfix completion template to it. So you can see right here, it shows a couple of them. I'll actually demonstrate each of these. So I'm just going to take the analog of what I just did with a live template, SD, and hit tab, and it resulted in the same code. Now, what you want to do is really up to you. This is one of those that is probably kind of an either or type of thing if you're typing it all from scratch. But if you have an existing expression and you just want to log it, so something like account.sd, it's very quick to be able to do that. There's another variant of this that it's new relative to what existed before in live templates, and it is say you have an in-memory object with kind of a complex hierarchical structure, and you want to log it in a way that that looks better and is more readable in terms of its structure inside the logged information. Value object.sd, and you'll notice SDJ, and what that's going to do, as shown here, is it's going to format it with JSON.serialize pretty. So you're going to actually get a nice structurally formatted version of whatever it is that you log. So I'm going to go ahead and do that, and we can see that value object has now been logged in a structurally formatted fashion. Now, a warning here, I do this all the time, but a warning, not everything can be formatted with JSON.serialize pretty. There are some objects that are returned from Apex system classes and methods that I don't know if they just bind directly to the underlying Java or whatever, but when you try to format them with JSON.serialize pretty, it just doesn't work. It may even fail in some cases. So you'll want to use that one judiciously, but it's available to you to be able to do that very, very conveniently. Okay, so moving on to the next one. Again, it's something I think a lot of people are familiar with, the ability to generate a for each loop for some iterable collection on the call stack. So let's just go ahead and just say iter, which is going to be the live template that existed. And what it's going to do is it's going to look for the iterable things on the call stack, and it's going to prompt you to select one. So we'll go ahead and just say, excuse me, account list. And it's going to, once I've chosen that, then it just prompts me for a loop variable, and then it puts me in the body and I can do something with it. Now, a lot of times you know exactly what you want to iterate across. So if I just said account list dot iter, and hit tab, there's no prompt required. Now I just have to specify, if I want to, the loop variable, and I can move on. Now, one of the other nice things about this is if you need to be able to iterate across something that's indirect. Now, the live template knows about maps and the fact that you might want to iterate across their keys or values, so we could choose their keys or values, but that's the only indirect thing it knows about already. But what if I wanted to iterate across something that's more direct? So let's say account list 0 dot, we'll just say account partners to 0 dot, what's another collection on this? Is there one? Yeah. Errors dot iter. So I can actually do that, and I can have arbitrarily complex chained expressions and then iterate across them. The way that you would have had to do that using the live template is you'd have to have extracted that into a variable and then iterated across that variable. But the nice thing here is you don't have to have that intermediate step. So it's a great way to be able to do these types of things to rather arbitrarily complex ad hoc expressions and then just say, this is what I want to do to that expression. So that's something that's very useful. And then, of course, you can not just do for each style loops, you can do index loops as well. So I'll do an index loop in the forward direction or an index loop in the reverse direction. Oops, I'm sorry. Did that wrong. I was trying to use the live template, account list dot for I. So do an index loop across account list in the forward direction and account list dot for R. And now we get a reverse loop. So you get the idea. And there are live templates for those as well, where you have to supply the actual bounds condition. And that's what I did at first, and then, of course, backed out of that. But the point is that there are live templates for each and for index fors. Now let's take a look at some things we can do with various types of expressions, and we'll start with Boolean expressions. Something I run into from time to time is I've got some conditional behavior I want to have happen based upon some very complex Boolean expression, and often it's not that expression, it's the not of that expression. Basically, I only want to do it if that expression does not evaluate to true. And so I have to formulate the positive expression often, and then I go ahead and negate it. And sometimes that's not the simplest version of it. I think you get the idea. So why don't we walk through it? So now you can take any Boolean expression and say not, and it'll negate it. Now this is a very simple one, but you can see that it put a unary not operator in front of it. And if I then do a dot not again, you would expect it to take it back to the original expression. And in fact, it does. So you don't end up with this accumulation of bang, 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 bang each time you say dot not. It's rather intelligent in that regard. So it should actually, if you do a dot not followed by a dot not, you should end up with the original expression. And you can see that also happens with relational expressions. It knows how to invert the relational operator backward and forward. For all these, I'll just go ahead and show one more example of this. It knows how to negate less than or equal to be greater than, and vice versa. And then it knows about some more complex expressions where it may need to add a parenthesized sub-expression in order to keep it valid. So dot not of an instance of, it adds parentheses. If I dot not that, it knows it can remove the parentheses. It knows on a ternary expression that it doesn't have to change the check expression, the first part of the ternary expression. It just needs to reverse the true branch and the false branch. And so that's actually exactly what it does, and then it'll reverse them back because the condition can remain the same. And of course, it knows with logical expressions that it can it needs to reverse the logical operator, and then for the operands, it may need to reverse those as well. So we can see that when I not this complex expression, and by the way, this is part of an expression hierarchy, so it's going to start with the closest leaf expression, and then it's going to walk up the hierarchy from there and allow you to choose which expression you want to operate on. And in this case, it reversed ands to ors and vice versa, and it reversed the relational operators as well. So you end up with a not of that. And then, of course, the other option would have been, for example, to just say not and then put parentheses around all that versus not. So, I mean, those are from a logic standpoint the same, and one may look more intuitive to you than the other. It's really up to you, but it gives you the ability to just use Boolean inversion to not a complex expression that you've already written. So anyways, hopefully that makes sense. Now let's move off of that to another thing you may want to do with an expression, which is adding parentheses for explicit order of operations or clarity or whatever it happens to be. And by the way, before I show the postfix completion on this, I wanted to also mention there is a context action that's available when you have such an expression for adding clarifying parentheses. This is something I use all the time when I program in Java. I added it for Apex quite a bit back because I use it there as well, because I really like to see explicit parentheses, even though they're not necessarily required because order of operations is already in place. place. But to me, this just looks like a more explicit version of the same thing. But if I wanted to add parentheses to various parts of this, I could just do .par, and it will again walk up the expression hierarchy, and I could add to whatever subset I wanted. So I can do that and do it again and add it to the whole thing. You get the idea. You can pretty much just very quickly make part of an expression, some or all of an expression parenthesize. All right, now let's move on to defensive programming and basically nullity checks and type safety checks and things like that. So if I have a variable and as I often want to, check and see if it's not null before I begin using it, there are a couple of options I have to do that. So first is the safe navigation operator that was added. And so we'll actually use that in this example, and we'll use a postfix template. So let's say that I want to know if the account number of this account, I want to have a certain behavior if it's not null. So I'll go ahead and just do account, and I'll use safe navigation operator and get the account number. And then I'm going to say not null in. And so we can see that this is a template that will create a conditional branching logic for if the expression is not null. And so I'll go ahead and do that. And it took care of that. Now, by the way, it's worth pointing out that account, we'll go ahead and do that same thing again, account number dot in, that's what we just used. There's a synonym for that, not null. Excuse me. So I'll go ahead and choose that, and it generates the same code. And if I want to do the other and check and see if it is null, I could do null, and it's going to generate an equals null. So the point is you can do very easily checks for null and conditional branching based upon that. Now let's go ahead and check for type safety. Now I'm going to show two different ways that you can do type safety. In both of them, the idea is that you have a reference to something through a more wide interface, so S-object or object or whatever kind of a base interface or base class, and you want to be able to work with it through a more narrow interface. So I want to work with this S-object as if it were an account. And there are really two different ways that you might want to do that. One of them is that you know that that S-object is absolutely an account because you've been putting it into a collection that is only available as S-objects, but when you pull it back out, you know you've only been putting accounts in there. The other is you need to test it first before you use it. So we'll go ahead and show examples of how you could do either one of these. So in this case, I know that this is an account. So I can basically, and I want to begin to access information off of it. So I'm going to say if definitely account dot, and I'm going to go ahead and cast it. So .cast, I'm going to hit tab, and now it's going to go ahead and wrap it in a cast operator. So it doesn't know what it could be. So I'm going to go ahead and begin typing. It's going to give me completion. And now I can begin to say account number not equal null. And then I'm going to go ahead and use statement completion, Control Shift Space or Command Shift Space, or I'm sorry, Enter, Control Shift Enter, Command Shift Enter to go ahead and complete that statement. And now we actually have a correct statement because I knew that that S-object was an account. Now, if we had already done an instance of, we can also safely assign to that type. So if I have already done an instance of, I can see definitely account dot cast var, and I can go ahead and see it's going to generate a strongly typed assignment effectively to a variable, cast var. I'm going to go ahead and tab. And so it went ahead and saw that there was a positive instance of against this type, and it went ahead and created a variable of type account and cast definitely account to that. So what if you had not already done that test, that instance of? Well, let's go down here and say that we have an S-object that might be an account, it might be something else, we don't know. So I can say maybe account dot instance of, and notice that there are two, inst, inst, and instance of, and they're synonyms for one another, whichever you want to use. So again, notice that it when it prompted me for a type, it showed me types that are assignable to S-objects, so subtypes of S-object. And now we actually have this ternary expression that's going to check and see if it's an account. It's going to make it an account or null. And then I can use an extraction refactoring to extract that into a variable, and we're good to go. So you can use each of those depending upon what you know about the data that you're working with and how safe it is to begin working with it using a more narrow interface. All right, and the last thing that I want to show, we're obviously getting on in time, is one that I actually don't use very often, but I think it's an idiom that folks coming over from other programming languages where object instantiation works this way may find to be more comfortable. So typically if I create an instance of something, so shopping list, mobile list controller equals, I'll say equals new, and then generally I'll go ahead and use smart completion. It'll find constructors of things that are assignable to the thing on the left-hand side. And so in this case, a constructor for a shopping list mobile list controller. But I can easily see if people want to say shopping list mobile list controller dot new, and then just hit tab, it'll go ahead and create a constructor for that. And I can go ahead and extract that into a variable, in this case, unique variable name controller 2. And of course, it's smart about the various constructor signatures. So if I say query.new and tab, then it sees that these constructors are available. So we'll go ahead and say shopping list underscore c dot s object type. And so now we have a dynamic query that we can begin building for shopping lists. The point is, it's kind of a postfix way to instantiate things that will turn into valid Apex. All right, so those are the out-of-the-box postfix completion templates. Hopefully what I showed makes sense, and it also makes sense how they relate to live templates and when you might want to use live templates and when you might want to use postfix templates. I think the best way to summarize it is to say use a postfix template when you know the exact expression you want to operate on, and especially if the exact expression is somewhat indirect, like I showed with iter against, several levels of indirection on a collection we wanted to iterate across. So I didn't have to extract that into basically a temporary variable. As far as finding out more about these, if you go into settings and go into editor general postfix completion, you'll see these. I have no idea why these are not in alphabetical order according to the languages. So you have to kind of go down to find Apex. So here they are. These are the Apex postfix templates. One bug I'll point out, not in IC, but in the JetBrains new UI, which I'm using here, is it looks like there's no description text, but it's there. It's just not visible unless you select it. I guess they're using the background color as a foreground color. I've already logged this with JetBrains. It's already been assigned to somebody, so you may not ever see this issue, but that's the reason you don't see description text. And it's not just here. I mean, you see it, here's TypeScript, the built-in ones as well. But the point is you can go through and you can take a look at the various postfix templates. It'll show a preview of kind of the before and after states, things like that. You cannot create or edit your own templates right now for Apex. That's something I might entertain adding in the future. I'd love to have your feedback on whether you'd like to see that. And additionally, if you're programming in other languages, probably JavaScript, maybe Python, Java, TypeScript if you're also doing Salesforce functions. There are lots of postfix templates out of the box for those languages. I didn't port over all of the ones for those languages that made sense to port over for Apex. I ported over about 15 or so that I thought would be the most immediately valuable. If you can think of ones that you use in other languages that you would like to use in Apex, let me know through an enhancement request. If you have ones that you've created that you think would be applicable for other IC2 users, let me know. I'll be happy to give you credit when I add it. And again, if you would like to see the ability to customize these, to add custom ones, things like that, let me know that as well. And I'll consider adding that in the future as well. Otherwise, if you see any bugs with these, let me know. And I hope you find them useful. I hope what I've shown here makes sense, and I hope you can incorporate this into your Apex development workflow. Thanks for your time, and take care.